Alright, today we are going to look at growth and decay that happens on a regular basis. Whenever something increases or decreases by the same percentage within the same time frame, it either grows or decays what we call exponentially. If you consider the following example, you haven't really seen exponential growth until you've seen what they call the penny problem. This is not the exact representation of it, but it'll kind of give you the idea. The penny problem is where they ask you if you'd rather have a job where you get paid a penny for your first day and your salary doubles, or if you'd rather be paid $1,000 a day. And what you're going to see is that the penny choice is actually the one that works better for you. So again, if you were given the option to be paid a penny the first day and have your salary double every day, or get paid $1,000 every day, it's actually smarter to choose the penny part, because if you take 1 cent and just say you purchase a painting for 1 cent and the value of the painting doubles every day, and you want to know how much it's worth in 20 days, we're just going to go through this the cheap way. We're going to multiply that by 2, so it's worth this much after day 2, day 3, day 4, 5, 6, 7, 8, 9, 10. So after 10 days it's still only worth $5.12. Continuing on, day 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. After 20 days, it went from being worth a penny and being $5 worth $5 on day 10 to now being worth 5,242 even on day 20. And so again, that is where the penny problem takes over, or where the penny choice takes over, because now if you could keep multiplying that number, that's day 21, 22, 23, 24, and after 25 days it's worth $167. So again, that's exponential growth. It didn't start off very fast, and you notice again after 10 days it was still only worth $5, but once it got up to a certain point and you continued applying that same percentage I was talking about, it grows exponentially because it takes off. And that is why whenever they graph your exponential growth, it looks kind of like this, because it starts out slow and then all of a sudden it just takes off. Exponential decay is the same way, where it goes down really quickly and then it just kind of slows and never reaches zero. If you remember, I told you about that graph, how the number never reaches zero on the asymptote. That is what we're talking about. So this is an extreme example of exponential growth, but the fact that the very same percentage was applied to a larger amount, which continued to grow, caused the amount to grow even faster. Percentages are tricky things. If you consider taking 50% of two numbers, and we'll take 50% because it's easy to calculate. Let's say you're an athlete and you sign a contract and your team offers you 50% of merchandise sales. In year one, your merchandise totals $10. Well, 50% of $10 means that it really wasn't a great amount, because you only sold $10. Half of 10, of course, means you only get $5 in that year one. But in year two, let's say you have a great year and for some reason your merchandise takes off. In year two, your merchandise totals $1 million. Well, half of $1 million, 50% of that is $500,000. So the same percentage of 50% had two different faces, and it depends on the amount. Again, whenever somebody talks percentages, that's why people ask for percentages, because it depends on how much you make. If a agent gets 10% of your contract and you're not a great athlete, they really don't make money off of you. If the agent gets 10% of your contract and you're a spectacular athlete or a spectacular musician or whatever it might be, then they get a lot of money out of you. That's why they want percentages of your earnings, not just a flat rate, because percentages, you get more if the person gets more, or you get more as the amount increases. So to the point of the lesson, you're going to be asked today to look at word problems to determine whether to use a growth formula or decay formula. Both of the formulas have the same general format except for one thing. The growth formula is A equals P parentheses 1 plus R to the power of T. The decay formula is A equals P times 1 minus R to the power of T. Write those two formulas down as I discuss what the letters mean. P is your principal. The principal is your starting amount. It is the amount that you begin with. So if you have a word problem where it says there are 500 people in a village, then your principal is going to be 500. If you start with a problem that says you invest $1,000 into the bank, then your starting amount is $1,000. So again, P is your starting amount and your principal is what we call it. R is your rate. It is the percent of interest or change that we're talking about here. If something changes by 10%, then your R as a decimal, if you remember 10% means we take the decimal and move it 2 spots back, is 0.10. If your rate was 5%, remember that we take the decimal, move it back, which means it is 0.05. That's going to be the trickiest part of the day, is making sure that whenever you see that you know what you're doing. So you understand, whenever I see percent, I think of 10% as 10 cents. Or so again, I kind of take it down to 10 cents, and on a price tag, 10 cents would be 0.10. Just like 5%, I think about it as 5 cents. 5 cents on a price tag is 0.05, because 0.50 would be 50 cents. So again, 0.05 would be 5 cents. So that's 5%. 0.10 is 10 cents, and so it's the same as 10%. The number 1, or sorry, T represents the time, which it could be days, years, anything they're talking about, and the 1 represents the decimal form of 100%. If you think about it again, 100%, move the decimal over, you end up with 1.00. There is no need to write the 00, so again, the 1 in this problem means that we are starting from the number 1. If it is growth, which is what we're talking about here, that is why we add more to the whole amount. So again, your principal is the whole amount plus a little bit more over a certain amount of time. If it's decay, then we say we take the whole amount minus a certain percentage over amount of time. So again, that is where you get your growth and decay from. If you consider 5% growth, it means we want the whole amount plus 5% more. Alright, whole amount plus 5% more. That would be like saying we want 100%, which is the whole amount, plus 5% more would give us 105%. In that formula that we talked about, it would be 1 plus 0.05, which gives you 1.05. If you take that decimal, or sorry, take this percentage and convert it into a decimal, notice that if the decimal's here and you move it back 2 spots, you end up with 1.05, which is exactly where this and that agree. So again, that is your percent version. This is your formula version, because remember, you have to have R written as a decimal. If you think about 15% decay, again, that is the whole amount minus 15%. So a whole amount, which would be your 100, minus 15%, which would give you 85% of the whole thing. The formula would show it as 1 minus 0.15, which again, if you type that in, I can do that for you, is 0.85. And again, if you think about 85%, which is this number, and you move your decimal back 2 places, that's where you get your 85% represented as 0.85. We do this, or we just did that, because part of our job is also to recognize growth or decay formula. So if you were asked if it's exponential growth or decay, all you have to do is look at the number that is going to the power. This number means nothing to us in terms of whether it's growth or decay, because this is a number that's going to the power. This number means nothing to us. That number means nothing to us. This, because it's bigger than 1, represents growth. This, because it's smaller than 1, represents decay. This, also smaller than 1, represents decay. This, 2, is obviously bigger than 1, again, which represents 100%, which represents growth. Alright. So now let's just take a quick look at some examples that will be added to your experience before we get ready for the test this Friday. Again, it's just 3 quick questions just to show you how this growth and decay formula works. It says, suppose your friend's parents invest $25,000 in an account paying 4% interest compounded annually. What will be the balance after 10 years? Again, use the formula A equals P parentheses. We've got to see if it's growth or decay. Your friend's investing. Anytime you're talking investing and you're talking interest, chances are your money is going to go up, because that is why people invest. They don't invest to lose money. They invest to make money. And so that is where we are. So we end up with A equals, P is my principal. I'm looking for the starting amount. And it looks like the starting amount here is $25,000. 1 plus your rate, in this case, is 4%. Keep in mind 4% is 0.04. That's what I want to put right there. And T is your time. Notice your time is 10 years. And all you have to do with your calculator is type all that in for yourself. 25,000 parentheses, 1 plus 0.04, close your parentheses, caret 10. And you get 37006.11. Give me 1 second and I will discuss what you have to do in just a moment. 37006.11. Majority of the money problems are going to be rounded to cents, so just keep that in mind. Also keep in mind that, again, you just type in exactly what you see and let the calculator do the work. The main thing is that you have to type in or insert the right numbers into the formula so that everything ends up the way it's supposed to. Alright, so again, there is no converting here. There's nothing else like that, and all of your calculators pretty much do that. Just make sure you use the parentheses and use the numbers in their proper spots and you should be okay. Since 2005, the amount of money spent at restaurants in a certain country has increased at a rate of 7% each year. In 2005, about $470 billion was spent at restaurants. If the trend continues, how much will be spent in restaurants in 2017? Once again, it says it is increasing at a rate, so you put A equals P parentheses 1 plus R to the power T because it's increasing. The hard part again is finding your numbers. Principal will be your starting amount. We're not really caring about the 2005 part. The part we're looking at is the money. The starting amount here is 470, and we'll just use 470 even though it's 470 billion because there's no need in putting that big of a number. We understand that our answer is in billions. Parentheses 1 plus. Our interest rate that is changed is 7%. Keep in mind that is 0.07. And then the time is where we have to do some work. This is where the 2005 comes in. This was in 2005 and we want to compare it to 2017. That represents a span of 12 years. If you don't know, you just take 2017 minus 2005 to find out that 12 is the difference between those two numbers. And once again, we simply type it in as is. 470 parentheses 1 plus 0.07 caret 12 equals 1058.53. And again, that is billion, which means it actually moves into the trillions because you have 4 digits in that. But either way, as long as you can get this number here, for the most part, I think you should at least be in the ballpark to getting the right answer on whatever the question is. But again, the bottom line there is that you need to make sure you understand how to find your principal, which in this case is money, your rate, which is 7, and the reason they gave you 2 dates is so you could identify the amount of time. One more example before we move on. The value of a car depreciates at a rate of 15% each year. Henry purchased a car for $50,000 in 2001. How much is the car worth in 2017? A lot of this is common sense. Just like I said about investing, you have to kind of use your common sense to think if someone's investing money, it has to be growth because I'm not going to invest money to lose it. Well, I don't know any car that gains value over time except for the ones that, of course, are model cars that they don't drive. But again, if you purchase a car for $50,000 and you depreciate, it's kind of like it decreases. So that means it's going down. So we're going to use A equals P parentheses 1 minus R to the power of T in this one. So in this case, again, A equals P is your starting amount, and again, you bought the car for $50,000. 1 minus your rate here is 15%, so 0.15. And time, once again, comes from the timeline here. 2001 to 2017 is 16 years. And so we take our calculator, type in 50,000, 1 minus 0.15 caret 16, and we find out that this $50,000 car is worth $3,712.55. And that is why if you buy a car, you need to take care of it. Typically, whenever you purchase a ar, if you purchase it for $50,000, the moment you drive it off the lot, there is a major decrease in price, because if it was brand new or if it was newer, the moment that it is off the lot, it just automatically loses a ton of value. So anyway, that is the game they play with you in terms of cars, and that is why used cars are much cheaper. Not much cheaper, but at least cheaper. Depends on how long they've been on the market. Hopefully the last example shows the power of exponential decay. Work on the problems for the day and continue to study for the test on Friday. Again, Friday is your test. It is the last test of the quarter. We will look at a review tomorrow, as in we'll do a review tomorrow. We'll take a pre-test on Wednesday. That'll give you a shot to see what's on the test and how you do. We'll review your errors on Thursday, and hopefully that prepares you for the final test of the quarter as much as possible. Attendance is extremely important this week if you want to do well. Otherwise, you risk losing information by taking days off. Again, you need to make sure you are here this week if you plan on getting the most out of this review, because what happens is if you miss some days and try to say that you shouldn't have to take the test on Friday, well, you've already known most of the information. Actually, you know all the information you need as of today, which means if you miss the rest of the week, it doesn't matter. You're still taking the test on Friday. So just be careful with your attendance and make sure you show up for this stuff. Good luck.